We're very fortunate to have a keynote tonight from Dr. Rachel Thomas, who will be speaking about why we need people from different backgrounds contributing to the development of artificial intelligence. Rachel is one of the founders of Fast AI, where she helped to create the most popular free online course on deep learning, bringing more people around the world with diverse and non-traditional backgrounds into AI. She previously was founding director of the Center for Applied Data Ethics at the University of San Francisco, with a focus on issues of surveillance, disinformation, bias, and justice in the tech industry. Rachel earned her PhD in mathematics at Duke University and was an early data scientist and software engineer at Uber. She was selected by Forbes as one of 20 incredible women in AI and was recently profiled in the book Women Tech Founders on the Rise. Please join me in welcoming Dr. Rachel Thomas to talk to us this evening. Thank you very much.
Great, thank you. Yeah, thanks so much for the lovely introduction, Sue. I'm super excited to be here tonight. And so I'll be talking about why you can and should get involved with AI. So Sue kind of covered my background. Two key interests of mine are getting more people involved with AI, as well as addressing and mitigating the ethical risk of AI and making sure that we're developing and deploying it responsibly. And to me, these two are very interrelated. I have moved to Brisbane permanently. Thank you. I'm super excited to be here, particularly at this time where there's kind of so much growth and innovation happening in AI in Brisbane, and it's just super exciting to see the launch of women in AI here. I'm going to be talking about several women tonight who inspire me and sharing some of their stories. And the first one is Sandra Lee, and she's an alum of the Fast AI course. And I should mention the Fast AI course is free. I'm not selling anything. And most people that take it are working professionals, often who already have successful careers and are either trying to apply deep learning to the area that they're working in, or who are pivoting in their careers. And so Sarada's background is she started off as an accountant and then went into machine learning and is now doing medical research on cell counts and cytopathology images. And this was joint work with some researchers at the University of San Francisco that's been published. And I should note that Sarada is from Perth, so a fellow Australian. And something I love about Sandra is kind of her journey. And so several years ago when she first got interested in machine learning, she wanted people to study it with her. And so she started a meetup in her living room with 7 other people originally, and she's now grown it to a meetup group of close to 3,000 members. This is the Perth Machine Learning Group. And prior to COVID, they were holding events 5 days a week, which I think is super inspiring. And they've had to, of course, modify their program with the pandemic, but they had a generative music group on Mondays, Fast AI course live streaming on Tuesday, lunch session for non-coders, presentations with networking, tech tinkering. And so I really love how Sandra kind of built the community that she wanted and needed along her journey. And she's moved on to where she is winning hackathons, she's giving presentations, winning awards, getting her work published. She was selected by Women in Tech Western Australia as one of their Tech Plus award winners. And so I think that's really inspiring to see. So I'm just making 2 points tonight. It's a short talk. And the first point is that you should get involved with AI. And the second is that you can, that it's possible. So why you should, why it's necessary for all of us to be working on this technology. And part of that is because of how much kind of potential it has. So another Fast AI alum who I admire is Elena Haley, and she's held kind of chief machine learning officer roles in several bioinformatics companies and is working to improve cancer treatment. And she's written some great blog posts on her work if you're interested. And here she's talking about identifying tumor variants and kind of improving her accuracy. She initially had a false positive rate of 28%, or this is kind of like the existing status quo with this data set, was a false positive rate of 28%, and kind of with the FastAI library and 17 lines of code, she achieved 93% accuracy. So just huge improvements. She's done some other great work on identifying the state of origin for metastasized cancer, and that's a really important question treatment-wise. So check out her work because she's doing some great stuff. And this, I think, kind of captures some of the positive potential of AI. Another kind of really positive application is art. And so Elena Sarin is doing another FastAI alum who is doing some really beautiful and innovative artwork that she's getting a lot of attention for, rightfully so. And you can check out her work on Twitter at Neural Bricolage. She shares a lot. And it was actually hard for me to capture. I was trying to capture like a representative selection of images, and she does such varied work that it was kind of hard to narrow in. And something that's really neat about her work is that, so she is both an artist and a computer programmer, and she does all the art she uses in her training data set. So she is doing the pastels and the drawing and the photography, and then she is writing all the code for her GANs that she's training on these data sets, and creating really innovative stuff as a result. And so I think that's beautiful. And I think all of you, I imagine, have things that you've thought about and that you want to see in the world that maybe nobody else has created or made yet. I love Helena's approach. So the co-founder of OpenAI tweeted a while ago, "I'm a simple man. I like to train big neural networks on giant computers." And Helena responded saying, "I'm a sophisticated woman. I like to train small neural networks on small data sets on small computers." And she kind of refers to her work as artisanal. And I really love that approach. And that's also something that really jives with our approach at FastAI. We're really interested in people that have small data sets and limited resources and small computers, and what can you do? Because those constraints are often the drivers of creativity. And so I wanted to kind of share some of the positives of what you can build with AI. But the other reason that I think we all need to get involved is to address and mitigate the negatives. And so I want to highlight a few things that can, go wrong. So another woman I admire is Dr. Latonya Sweeney, not a FastAI alum, but she's the director of Harvard's Data Privacy Lab, and she has her PhD from MIT. And about a decade ago, she noticed that when you Google her name, or at the time when you Googled her name, you would get these ads saying Latonya Sweeney arrested, suggesting that she has a criminal record. And she does not. She's the only person by her name. There's no Latonya Sweeney with a criminal record. And this is something that could really color an employer's perspective if they were Googling someone. However, when you Google other names like Kirsten Lindquist, you get much more neutral wording. Just, "we found Kirsten Lindquist." And Latonya is a historically African-American name. Kirsten Lindquist is a historically European-American name. And Kirsten Lindquist actually has a criminal record. She's been arrested 3 times, yet she has this more neutral wording. And being a computer scientist, Dr. Sweeney wanted to study this systematically, so she looked at over 2,000 names and found that this pattern holds, that traditionally African-American names are getting these very biased ads. And she published this work, and we've just continued over the past decade to kind of see more and more examples of how this plays out in various ways in the kind of ad-supported ecosystem, which is most of the major tech companies are running on ad revenue. And this is just one of many examples of where bias shows up. A second issue that concerns me about machine learning and AI is that when errors happen, they can happen at scale. And so we saw this with Robo Debt, and Robo Debt does not use AI. However, this this type of problem, I think is only going to potentially happen more and more with AI systems since they are at scale. And so here, over 600,000 people were unlawfully issued debts for money they did not actually owe. This destroyed many, many lives. And the Australian government went from investigating, I think, 20,000 welfare recipients per year for potential fraud to generating, 20,000 debts per week. And so they had really, really scaled up what they were doing without any sort of mechanisms in place to kind of prevent this huge harm. This shows up in so many contexts, and I think it shows up in social media a lot. And so, in a very, very somber way, we saw with the genocide in Myanmar, which the UN ruled that Facebook had played a determining role, and that's something that did not come out of the blue. It didn't happen overnight, but locals had been warning Facebook execs as early as 2013 about how the platform was being used to incite ethnic violence. And they kind of kept issuing these warnings, and Facebook failed to take effective action. And you had kind of a whole country coming online very quickly, and very incendiary and dehumanizing hate speech being spread at scale. And third kind of issue, and also I should pause here and highlight that these issues are all of them are inherently interdisciplinary. These are not just things that computer scientists can fix on their own, but these are issues where we really need policymakers, we need people that work in local government, we need lawyers, we need social workers. We really need people from all backgrounds to address these sorts of uses and these sorts of issues. And then the third and final kind of ethical harm that I'll highlight tonight is feedback loops. And a feedback loop occurs when your model is the data that it generates then goes into the next round of predictions. And so your data has kind of become contaminated in a sense, like you're both kind of creating the input and the output. And so one example of this is in predictive policing. And so the idea with predictive policing is you have an algorithm recommending, send more police officers to this neighborhood, and, you don't need to send police officers to this neighborhood. But the issue is that then if you have more police in a neighborhood, they're likely to make more arrests. And then that data is going to feed back into the algorithm and say, okay, you should, send even more police there. And you start kind of creating the outcome that you were supposedly predicting. And this is most common in the United States and the United Kingdom. Unfortunately, there has been a little bit of work in Australia, in particular. New South Wales has a police program that does have an algorithmic component and was found by Australian researchers to be disproportionately targeting Aboriginal youth. And often there is this overlap kind of between bias and feedback loops as well. And I should say this mechanism of feedback loops is the same thing that's at play with recommendation systems. And so for me, ethics issues really underscore why we need everyone involved with AI. We need greater diversity, and that's, I think, in all dimensions. And so definitely people from marginalized genders, more women, more non-binary people from kind of all geographic locations, people of all ages. Racial diversity is incredibly crucial as well. And we need domain experts from other areas. As I was mentioning, these are really, really interdisciplinary problems that are going to require domain experts in other areas with a deep knowledge of AI. We need more people from the humanities and social sciences because they bring such a valuable perspective and valuable set of tools. And increasingly, I think everyone in society will need a level of AI literacy. So only 12% of machine learning researchers are women. This is a study from a Canadian group at Element AI. So the statistics are pretty grim, and it's actually even grimmer when it comes to race. We really do need more Black and Indigenous researchers in this area. And I should also say we really need to stop the toxic environments that drive people from historically ignored groups out of the field as well. Kind of a positive story on on kind of what having a diverse team can offer. So someone else I admire is Tracy Cho, and Tracy Cho was a early engineer at both Quora and Pinterest, and she's now founder of Block Party, which is trying to address online abuse and harassment. So I think she was employee number 5 at Quora, and she wrote that the first feature she implemented at Quora as a software engineer was the block button, and she was really eager to work on it personally because she was being harassed on the site. And she says if she hadn't been there, she thinks that they would not have implemented it nearly as early as they did. And so I think this is a kind of positive story of how a diverse team can kind of address problems earlier. So that's kind of some of the reasons why you should get involved. And I should also say it's not really this binary between, this is positive building stuff and then this is, addressing the negative mixes. I think in messes, in many cases, it's a blend of, you have something you want to build, and then you also want to build that in a responsible way that tries to avoid these pitfalls and potential harms. So hopefully I've made the case that you all should get involved with AI if you're not already. The next question though is that even possible? You might be worried that you don't have the right background for it or that you don't have the resources to do so. And I'm here to say it is possible for you to get involved, and I really hope that you will. And so I want to address that I talk to a lot of people that think that that have a lot of math anxiety. And there's a beautiful essay by Paul Lockhart called A Mathematician's Lament. And he writes about this nightmare world where children are not allowed to sing or play music until they are in graduate school. And so they need to spend 2 decades learning formal sheet music notation and transcribing scales by hand and memorizing all the formal notation before they can be allowed to sing. And that's a terrible idea, right? Yet that's how we teach math often. And so many people are really turned off to math kind of through the methods it's taught. It's also often taught in a very vertical way where if you have a bad year one year, you're kind of screwed every future year because it builds on itself. There's all sorts of research on how, at least in the US, girls pick up on anxiety from female teachers, and female primary school teachers have particularly high levels of math anxiety. There are a lot of racial stereotypes as well around who's supposedly good at math and who isn't. And there's also a really, really deep-rooted myth, and this holds in both math as well as I think in computer science and coding, of this idea that it's about innate ability. And Dr. Omaju Miller, who is a machine learning engineer at GitHub and also studied this in her PhD, has written a great essay about it. But this is totally a myth. This is not what the research supports. They're not certain kind of brains that can do math and certain kind of brains that can't. But when we believe that, it becomes a self-fulfilling prophecy. So I just wanted to take a moment to kind of talk about some of the cultural factors that have led many people to feel like they don't belong or that they're not capable. And a while ago, because I still hear this message from people, people will say like, oh, if you don't love math, you can't do machine learning. And that's not true. It's never too late to start. And so kind of arguing with someone about this on Twitter, where this guy had said, oh, you have to have loved math when you were a teenager. Otherwise there's no hope for you. And that's not the case. And got some really inspiring responses from people. Data Science Renee, who's a successful senior data scientist and has a popular podcast and blog on data science, shares that she didn't take any advanced math until she was in her 30s. I also got someone that responded that they're learning machine learning for the first time as a 50-year-old with straight A's in their PhD program in bioinformatics. And so I found those to be inspiring. All that to say, though, we actually, with the Fast AI course, we specifically didn't want to have advanced math prerequisites, and we don't. We really wanted to focus on the practical aspect of coding. Everything I said holds true for learning to code as well. And so we really wanted to take people to state of the art with coding, and felt that kind of a lot of resources, particularly when we started, were kind of overly focused on the theoretical and kind of wanting you to learn kind of all this advanced math theory before you could actually just build a model for the problem that you care about. And we kind of wanted to get there right away. And so that's what we do with the course. Another myth that I hear a lot is people who believe they don't have enough data to use deep learning. And so, and it's totally understandable because the big tech companies really promote this of, if you don't have a Google-sized data set, you can't do this. And that's not the case either. And so this, one of our students downloaded just 30 images of people playing cricket or people playing baseball, and that was enough to train an incredibly accurate classifier. And so with a technique called transfer learning, you can actually do a lot with a relatively small data set. And I think there's so many kind of really interesting small data sets out there. Another myth out there is that you have to have Google-sized computing resources or Google's budget. And so a few years ago, Stanford hosted a competition called Dawn Bench, and it was a speed test for ImageNet. And I'm super proud of the FastAI team. They went up against, this is a group of FastAI students, together with Jeremy, and they went up against teams from Google and Intel that had access to way more resources and much larger budgets. And so this was to see who could reach a certain accuracy on ImageNet the fastest and the cheapest. And FastAI achieved the lowest actual cost, fastest on GPUs, fastest on a single machine, fastest on publicly available infrastructure, and faster than Intel's entry that used 128 machines. And this is common at many of the big tech companies of kind of just throwing more money and more compute at problems, whereas resource constraints actually force you to think more creatively. And can really, I think, be an advantage. And also, most of us in the world are resource constrained. And so kind of what you build transfers better if you're dealing with resource constraints. At the time, the one submission that beat us was Google had an entry using TPUs, and they were not publicly available back then. This is tensor processing units. However, a few months later, FastAI came back and released results 40% faster than Google's TPU results. And so this was thank you. Yeah, so it was really exciting to kind of show that like you can do state-of-the-art work with limited resources. And it was covered by The Verge and the MIT Tech Review. And Jeremy also wrote up about a lot of the techniques that we used, and Google and NVIDIA and Intel and ended up implementing many of these techniques into their own programs. And then I'll just share kind of one final story. So hopefully this is kind of made the argument that it's possible for you to get involved with AI. So one more FastAI alum I'll talk about is Melissa Fabros. And Melissa was a PhD student in English literature, focused on American poetry, and decided to switch careers. And she's actually been my student twice. And so I taught her when she was first becoming a software developer many years ago. And then she ended up focusing on machine learning. And she's been working at Kiva for the last several years. And Kiva is a micro-lending nonprofit that lets people make and receive small loans, such as this Kenyan farmer. And Melissa discovered, in working at Kiva, that computer vision classifiers did a very poor job of recognizing Kiva users, since Kiva users are of all ethnicities and kind of all over the world. And so Melissa won a large grant to build a more representative data set. And I think this is a fantastic project, and I was really excited to see that happen, as well as just to kind of watch her journey in the field. And so, with that, I'll close. We really need all of you. We need all of you helping to shape AI and how it's implemented in the world, and kind of regardless of what your background is. I think you probably have special talents and skills that maybe even seem perhaps irrelevant to AI, but are actually super useful and super important. Thank you.